Hello and welcome to this lesson about writing linear functions, part 2. The learning target for this video is writing linear functions in slope-intercept form in pretty much any circumstance or situation. So first, let's start off with a quick recap. We need to remind ourselves that slope-intercept form is y equals mx plus b, and that we have 1, 2, 3, 4 variables, 4 pieces or 4 spaces for information to go into. And what's going to happen is that you're going to be given different combinations of these points. Now, ultimately, we must have two things. So must have 1 is m, 2 is b. And what happens as these problems get more complex is that you end up using not 1, but 2 points to get this information. So let's take a look at some examples. Let's say we're supposed to find the line, the slope-intercept form of the line that passes through these 2 points. 3, 2, and 5, 6. There we go. Okay, so the first thing we have to do is use these 2 points to find slope. So use to find slope. So we'll use the slope formula to go 6 minus 2 over 5 minus 3. That gives us 4 over 2, which we can reduce to 2. So now this is equal to m. I like to put a circle around it just to know, hey, this is a useful piece of information. Because what we need to do is get y equals mx plus b. So what we've now done is found m. Y equals 2x plus b. And now this is starting to look like some of the problems that you've probably seen before, where you have a slope, you have a point. Doesn't matter which one you pick, so I like to pick the one with the smaller numbers, and we just have to solve for b. So when I do the first point, I'll get 2 equals 2 times 3 plus b. That gives me 2 is equal to 6 plus b. If I subtract 6 from both sides, I end up getting b equals negative 4. So now I have m, I have b, I can bring it all together. Y equals negative 2x, no, sorry, not negative 2x. Sorry, y equals just regular 2x minus 4. Box it. Walk away. We have found the equation of that line. Let's do another example. Let's take a look at another example. Again, we're going to use these 2 points to find our slope. So we have 3 minus 0 over 1 minus negative 4. That gives us 3 over 5, right? Yep, 3 over 5. Okay, this is equal to m, so we'll put that in our back pocket. And we know so far that we have y equals 3/5 x plus b. Now, the point of this one is to show that sometimes, these aren't always really nice. But we can still work with it. So what I'm going to do is I'm definitely going to choose this point. And I like this point because I see a 0 in there. So that means that one of the variables is going to disappear and make it a lot easier to work with. So 0 equals 3/5 times, let's see here, negative 4 plus b. So now I have to have to do some multiplication, and I'm going to end up getting 0 equals negative 12 over 5 plus b. That's totally fine. I'm going to continue to use fractions. I'll add 12/5 to both sides, add 12/5 to both sides, and b equals 12 over 5. I have m, I have b, y equals 3/5 x plus 12 over 5. I box that, and I walk away. So that's how you can find the slope from 2 points. Or sorry, the equation in linear form or in slope-intercept form in 2 points. You have to first find the slope, and then you use either point. Doesn't matter which one you end up using to find the intercept, and then you bring it all together. Now, let's talk about word problems. For word problems, again, we have to look for a variety of things. It's sort of a combination of a bunch of different things. So we're going to want to look for M, but that's going to be in the form of something that has, constant change. We might want to look for B, which is a starting point. And then we have to look for some X and Y points. X and Y, X and Y. And so we need some sort of combination of all of these in order to make a linear function in slope-intercept form. But when it comes to X and Y, we also have to be mindful of, what does X represent? And what does Y represent? And so we have to remember that X is considered to be the independent variable, and Y is the dependent variable. Now, more often than not, time is an independent variable. And there's a lot of word problems that are cooked up around the notion of time. In fact, we'll do an example of one in a minute. And then dependent is whatever else there is. But usually I also think it's easier to find the dependent variable. You ask yourself, all right, what kind of relies on something else? And then you found out what Y has to be. Because often there will also be a question you have to solve with these word problems. So let's take a look at an example here. Let's look at this one. I tried to keep the numbers simple so we can really focus on the concepts and ideas. Tommy needs to save $50 for a toy. He currently has $10 and he can save $5 a week. How long until he can buy this toy? So again, what we're looking for is a combination of M, B, a point to work with. Now this one is in the most basic format you'll probably see when it comes to these types of word problems. I see two numbers here, 50 and, 50 is extraneous information, we don't need that one, 10 and 5. He currently has $10. Well, currently has $10 makes that sound like a starting point. So our starting point is $10, which means that's what is equal to B. He can save $5 a week. That sounds like a constant rate. And anything that's a constant rate is going to be our slope. So M is going to equal 5. Make that a better 5. There we go. So we have $10 for our starting point, and then we have 5 for our slope. We can bring it together. Y equals mx plus b. Y equals 5x plus 10. Now, we also have to think about what do x and y represent in this problem. X, like I said, is usually time. So this is going to be weeks. Y is money. Now that comes in handy because we have the $50, which is now no longer extraneous information, and we need to plug that in. Well, if you plug it into X, you're not going to get the right answer. You have to understand the units. $50, dollars is Y, so 50 will go into Y. And so that ends up giving us, so we need to solve or answer the question, 50 equals 5x plus 10, and we can solve that to get x equals about 8 weeks. Now, let's look at a different variation of this. So this essentially is the same problem, but spun a different way. Tommy needs to save $50 for a toy. After saving for 2 weeks, he had $20, and after 5 weeks, he had $35. How long until he can buy this toy? So in this one, we're not going to be able to find B, nor are we going to be able to find M. We can't find a constant rate of change. But again, if we label and identify what is X and what is Y, what those things represent, then that's going to help us find some points. So X, again, is usually time. So this is going to be weeks. We already know it from the previous problem. And Y is going to be money. And so when we look at this 50, not useful right now. But this 2 and 20 is. And notice there's already a comma right there. It's like the word problem gave us the point, 2, 20. And then 5, 35. Just make sure that the units match up. 2 weeks, 5 weeks. Both in the X. Dollars are in the Y. And now this looks like some of the other problems we did earlier, where we have to find the slope. And so we would go 35 minus 20 over 5 minus 2. That gives us 15 over 3, which equals 5. And then I don't want to go through it all the way and bore you to death here, but you can kind of see how this works. We found m. You just plug in any of those points. You're going to get the same equation. You then go back to this, and you answer the question. So when it comes to word problems, you're looking for a combination of m, b, or a couple of points. It definitely helps to identify what x and y are, like what the unit is, what they represent in the problem, because it makes it easier to then put everything in the right place and to answer the question. Because for example, another variation of this is instead of saying how long until he can buy this toy, it could be something like, will he have enough after 9 weeks? Well, once you have the equation, which is y equals 5x plus 10, you can plug 9 into x right there, and you can find out. So again, the questions can vary, but if you are able to identify all those different pieces, it's up to you. It'll be very easy for you to kind of put in the places where they belong, answer the question, and be successful every time. So good luck with your homework or practice, and let me know if you have any questions.